here is just a review of what a function is. So they do it almost like a process, like a box here as far as showing a picture of what this looks like. Domain, remember that is your x values. And so if we talk about domain, we are talking about our x values. And we put those values into this function, whether it is x plus 1, x plus 2, 3x, whatever it is, something is happening to the x. You put it in, you process it. That means you just evaluate it. Just like when you plug in an x, you evaluate it. And your answer is, of course, your y. All right, so your x is your input, what you're putting into the function, and your y is your output, which you are getting from the function after you have actually done it. A function rule is the equation that pairs the domain with the range, or that pairs the x with the y. These are function rules. Now you have seen them before, because a function rule is really just the equation itself. So if you look here, you see f of x equals 3x plus 2. This f of x is our function notation, all right? This is the same thing as y. F of x and y are the same thing, all right? It's just another way to write it. What you're saying is that this number that you get when you put the x in is a function of x. It's a function of x. And so it's telling us, given the domain or the x values of -3, -1, 0, 2, and 4, and the function rule f of x equals 3x plus 2, represent the function as a table, a set of ordered pairs, a graph, and a mapping diagram. All right? So how do we do this? Well, we've done this before. The first way is to set up this table here. We have our x values that they actually gave us, -3, -1, 0, 2, and 4. We have the function 3x plus 2. So then how do we get our y? Well, we just plug it in. 3, instead of x, we write our x value, -3 plus 2. 3 times -3 is -9, plus 2 is -7. So my y value here would be -7. And that's how I get my first ordered pair. My x was -3. When I plugged it in, I got -7. And we're going to do that for all 5 of those. -1, when you plug it in, 3 times -1 is -3, plus 2 is -1. So you'll see that my x value at -1 was -1. And my y value was also -1, because that's what I got when I plugged it in and solved. 0, what happens when I plug in is 0. 3 times 0 is 0, plus 2 equals 2. So you'll see that my ordered pair here was 0, 2. I want you to notice the notation here. F of -3. All they're saying is what happens when you plug in -3. You don't do anything with the f of -3. It's just telling you what number to plug in, all right? And they plugged it in. So you don't divide by -3. You don't do any of that. That's just telling you what number to plug in. It also wants us to do a graph. Well, now that I have all of my ordered pairs down here, I can just plot those on a graph. So I can plug those in, and we all know how to do that. X moves us left and right. Y moves us up and down. All right? And so once we do that, we can plot it on a graph, and we can see what it looks like there. Another way that we did it with our last section is a mapping diagram. And for my mapping diagrams, you do have to label them. We talked about that. Domain and range. So you put all of your x values in one, all of your y values in the other, and you draw an arrow. And you can easily see that these are functions that we're doing, and they told us it was a function rule as well. And so function rules are just the equation that they give you that tells you what to do with your x to get your y. That's all a function rule does. It's telling you what you're going to do with your x in order to get your y value. Let's look at one more example, and then we're going to graph some. This wants us to graph the function y equals absolute value of x. Now you'll notice it did not give any domains. All right? So it's going to let us choose our own domain here. And they actually, in this example, they chose -3, -1, 0, 2, and 5. Now, if you are given a function and I do not give you the domain, you can choose it. So here's what I would recommend you do. I would recommend that you choose some negative numbers, just like they did. I would recommend that you choose some positive numbers, just like they did. And I would recommend that you always choose 0, okay? Always choose 0. So choose a couple negative numbers, a couple positive numbers, and also choose 0, all right? I would also recommend you put them in order from least to greatest. It's the best way to see what's happening with the pattern of your function when you graph it, all right? Once you choose your numbers, so your first step here is to choose your numbers, choose your x values that you're going to use, and then you're just going to plug them in. Plug them into the function that you've been given. -3, well, the absolute value of -3 is 3. And so that tells me that I have a ordered pair then of -3, 3. Plug in a -1, I get 1. So -1, 1. Plug in a 0, I get 0. Plug in a 2, and then plug in a 5. And so once you set this up, you have your ordered pairs. Okay? You have your x's and your y's. They want us to graph it. In this case, they didn't give us x's and y's, so we're going to graph those points, but that's not where we're going to stop, okay? We're going to graph those points, but because they didn't say, here is your specific domain, that's all you have is this domain, like they did on the first one, then you have to assume that every number in between could also have been used, okay? And that it goes on infinitely. And so when you have something like this where they do not give you the domain and you choose it, you want to actually connect those dots. And so you want to take this and you want to connect the dots because you're telling them that, okay, not only is it the dots that I chose or the x values that I chose, but it's also every single number in between. And so by putting the lines there, you're saying it's every number in between. So you'll notice in your book that they actually have the graph that looks like this without even the points labeled because it's every single point in between. So far, they have handed us the function and say, okay, give me the y value. Here's the x, here's the function, now give me the y value. In these next few examples that we're going to do, they are actually giving us the x and y in some way or another. They're either giving us the x and y in chart form, they're giving us a graph or like a table of points. And then they're saying, I want you to tell me what the rule is. So this is very important that you look for patterns in what's happening between the x and the y. You're looking for a pattern. All right, so if you look at this first one, you have -2 gives you a 6, -1 gives you a -3, 0 gives you a 0, 1 gives you a 3, and 2 gives you a 6. So the first thing we're going to look at is we're going to say, well, what's happening from x to x? All right, what is happening from x to x? Well, x is just going up by 1. Does everybody see that? So if I go from -2 to -1, I've just added 1. That's a positive 1. -1 to 0 is also a positive 1. 0 to 1 is a positive 1. And 1 to 2 is a positive 1. Right? That's the only thing that's happening between the x's. Well, what's happening between the y's? Well, the y's are going up as well. -6 is going up to -3. So how much is that? Positive 3, right? What about 3 to 0? Also positive 3. What about 0 to 3? So we see this pattern emerging. Every time x goes up by 1, y goes up by 3. So what do I probably need to do to my x to get to my y? Right, so if you look at the comparison between the two, how do I get from -2 to -6? Well, I multiply by that 3. -1 to -3, multiply by 3. 0 to 0 is the same, 1 to 3 and 2 to 6. So my rule here would be, well, yes, this is a function, f of x. So how do I get to this line, f of x? Well, I get to it by taking the x and multiplying it by 3. I take that x and I multiply it by 3, and that's how it works. And you can check this. Plug in any of your x's and see if you get your y. Well, yes, if I plug in a -2, 3 times -2 is -6. If I plug in a 1, 3 times 1 is 3. So you can see that this rule works. This would be my rule for this particular function. F of x equals 3x. That is the pattern there. Let's look at the next one. Example 4. Find the function rule for the graph. And they've given us this graph here. They didn't give us any x and y points. So here's what we're going to do. We're going to pick some just like we would. So I'm going to pick the ones that are definitely on a cross. So I'm not going to pick one that's partially in between two where I have to say, is this 1/2? Is this 1/3? I'm going to pick one that crosses directly on it. So if I were choosing this, and we'll use the ones they chose as well, this one is directly on it. That is, and I think they go up by 2's here. They didn't actually tell me. Yeah, there we go. So this is -4, -1. All right. If we look at this one right here, this is -2, 0. All right. I like to always choose my 0 if I can, if it's on a perfect one, and this is 0, 1. Look at a couple others at 2. At 2, this function is at 2. And then if I move to 4, this is 4, 3. So I have 5 different numbers here. And so it's easier to see it as a chart, so I'm going to do the same thing. I'm going to chart those 5 numbers with my x's and my y's. So I'm going to say I have my x's here and my y's here. When x is -4, y is -1. When x is -2, y is 0. When x is 0, y is 1. When x is 2, y is 2. When x is 4, y is 3. All right? And then I'm going to see what's happening here. Well, for this one, my x's are changing constantly. How are they changing? A positive 2. So all of these are positive 2's. How are these changing? Right, positive 1. All right, for this one, if I put how this is changing over how that is changing, I actually got what was happening here, all right? What's happening between the x's and the y's here? What's happening between the x's and the y's here? For every 2 x's, y is increasing by 1. All right, so that's true. We have to consider a couple things here. There's not a definite pattern from x to y. Do you see just a multiplication pattern from x to y? No, there's not. All right. We can see that obviously there's some reduction at some point, because here, if you look here, my y is smaller than my x, right? Or but x larger than my x. So I know I'm doing something here. Here, y is larger than x. Here, y is larger than x. Here, it's the same. And here, it's smaller, right? So there's something else that's happening here. This one's a little bit more difficult to see. One of the things you have to say is, well, there is a difference in the x values by 2 and the y values are by 1. So there is a possibility it's 1/2, right? We don't really see that, but what happens when I take it by 1/2? Well, if I take a -4, and let's say we're just multiplying everything by 1/2, what does that give me? That gives me -2. What happens when I take -2 by 1/2? It's a -1. What happens when I take 0 by 1/2? 2 by 1/2, 1, and 4 by 1/2, 2. So now let's compare that to what it actually is. -1, 0, 1, 2, and 3. Now if I look at these two, from -2 to 1, -1 to 0, 0 to 1, 1 to 2, 2 to 3. What's happening from this row to that row? I'm adding 1, right? If I add 1 to -2, I get -1. If I add 1 to -1, I get 0. So I have to take this 1/2 x row and I have to do what to it? I have to add 1, right? To get to the actual answer. Does everybody see that? So the 1/2 row didn't work, did it? It didn't give me my actual y values. My y values are down here. If I take my x values and multiply by 1/2, which looks like that's what it's going to be because I'm going up by 1 and going up by 2, right? I didn't quite make it. This is not my actual y values. I haven't quite made it. But if I take all of these and just add 1, I will get my y values. Everybody see that? So my 1/2 didn't work exactly. But if I take the 1/2 x and I add 1, I will get my actual y values. So if I take my x's and I multiply them by 1/2, I don't get my y values. But if I add 1 more to them, I do. So my y values equal 1/2 times my x plus that 1. So this sometimes gives you a picture, like here it was exact. All I had to do was multiply by 3 and it was exact. This one didn't get me there yet. So it's always good to test it and say, what does it give me if I multiply by that 1/2? I know it's going up in a ratio somehow from 1 to 2 because one line is moving 1, the other one's moving 2, but not quite. So I made this extra row here. This extra row, I added in and I did the 1/2. And I saw it didn't give me my answer, but now I see a pattern between these two rows. The pattern between those two is I just need to add 1 more. And so that tells me that I'm going to take that 1/2 and I'm going to add 1 more to it. Add 1 more to it, and that will be my rule. So sometimes they're really straightforward and you can see the pattern. Oh yeah, I'm just multiplying my x by 3. Sometimes you're not going to see a perfect pattern. And so you're going to have to use how they're moving to help you kind of transition to what happens after that first multiplication. When it's just multiplying or adding or subtracting, it's really easy. But when it combines the two, you have to look for a pattern between the partial and the whole. All right? All right, so in this case, it just gave me a bunch of ordered pairs. So I need to figure out what they are. All right? And so if you look, -3 pairs up with +9. So this one is -3, 9. -2, well, the y value there is 4. -1, the y value there is 1. 0 and 0. +1 and 1. +2 and 4. +3 and 9. And so we make this chart. Now you'll notice that the top row is going up by 1s, right? The bottom row seems to be changing, right? It's going down, right? Down by 5, 3, and 1, and then up by 1, 3, and then 5, okay? So there's not really a pattern that you can see between the x's and how they're changing and the y's. You'll notice on the other two, the x's changed at the exact same rate, the y's changed at the exact same rate. So we could actually compare those two and say, hey, there is some relationship between how they're changing, all right? With this one, y is actually not changing at a constant rate, right? Y is going down and then y is going back up. So it's not changing at a constant rate. So the second thing we're going to look at is there a comparison between my x's and my y's? So how would I go from -3 to 9? You can multiply it by what? -3. Well then, can I multiply -2 by -3? That doesn't help me. What do I multiply -2 by? -2, right? What do I multiply -1 by? -1. So there is a pattern. What are we multiplying every x by? Itself, right? So we're actually taking x and we're multiplying it by itself. There's another way to write that. How would I write x times x? X squared, right? Which is what my function actually is. So in order to get y, I have to take x and I have to square it. I can check it. Does that work for every single y that they gave me? Yes. If I plug in a 3, I get 9. If I plug in a -2, I get 4. It works for every single x. So I know that this is my function rule. This is my function rule. Question. So what's happening from x to x? Well, how do you go from x to x? You're adding 2, right? Those are all going to be +2. How are you going from y to y? Hey, you're subtracting 1. So what is your rule? Dawson, did you want to answer this? What's your rule? So -1/2 times x. How do I go from x to y? Well, to go from x to y, I have to divide by 2, which is 1/2. But it's also changing signs, right? It's also changing signs. So when you look at this pattern right here, the first thing you want to do is put how your y is changing over how your x is changing and see if that works. See if that works. If it doesn't, then see if that line helps you, okay? So -4 times -1/2 is +2. Correct. How do I go from x to y? How am I getting from x to y? And sometimes it will be plus or minus, and sometimes it will be multiplication, and sometimes it will be like the example 4, where you have to multiply by something and then add or subtract. So anytime you're doing this, look at your pattern of your x's, look at your pattern of your y's, put your y over your x and see if that multiplication works, all right? If it doesn't, now this is only true if it is constant, meaning these are all -1 and these are all +2s. If something is changing differently, like it was on the square, then you're not going to have a constant rate over a constant rate.